For this video, we're going to review for our upcoming test. So everything we've covered so far in this unit is part of the coordinate geometry unit, and we started with distance and length. So you have our distance formula, our midpoint formula down here. Then we looked at the Pythagorean theorem, right, which goes along with the distance and length. And then we talked about simplifying square roots, where you have to make your factor tree. All right. Then we looked at perimeter, area, and circumference of different types of polygons, and then we looked at those geometric figures and the properties of them and describing and labeling different shapes based on the properties that they have. So now we're going to go through some of the examples that we didn't get to in class. So for the first one, we're given the midpoint and one endpoint of a segment, and we want to find the other endpoint. So remember, your midpoint formula is that the midpoint equals, and then you've got the average of your x's, you add them together, divide by 2, and then you add your y's together and divide by 2. So in this case, it's a little different because instead of plugging in both of these points to this part, the midpoint is given to us. So I have -1, -2 equals, and then I've got 3.5 plus x divided by 2, and -7 plus y divided by 2. Well, now I know that the 3.5 plus x over 2 has to equal -1. And -7 plus y over 2 has to equal -2. So I've got -1 equals 3.5 plus x divided by 2. And multiply both sides by 2. Start to get x by itself. So I got -2 equals 3.5 plus x. Subtract 3.5. And -2 minus 3.5 is -5.5. So the x value of our endpoint is -5.5. Now to find the y value, do the same thing, but I set -7 plus y divided by 2 equal to -2. And we'll multiply both sides by 2. So we get -4 equals -7 plus y. Add 7 to both sides, so then y equals +3. So my endpoint is at -5.5, 3. Then we want to find the perimeter in number 4 of a polygon with vertices at C, D, E, F, and G. Okay, so I want to find the perimeter area, so I'm just going to graph it. So you have -1, 1, 3, 4. It's kind of hard to see my x and y axis here. 6, 0. I believe is right there. And 2, -3, and -4, -4. And so that is C, D, E, F, G. So I've got this 5-sided polygon, which we call pentagon. Okay, so to find the perimeter, I have to add up all the sides. Well, I can't count any of these sides directly because they're not horizontal and vertical. So I'm going to use a distance formula to find the length of each side. So I'm going to start with CD. And just to recall, our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so for CD, x2 is 3. So I've got 3 minus -1 squared plus 4 minus 1 squared. 3 minus the negative becomes plus. 3 plus 1 is 4. 4 squared is 16. 4 minus 1 is 3. Squared is 9. 16 plus 9 is 25. Square root is 5. So CD is 5 units long. Then I'm going to do the same thing for DE. Okay, so now I've got 6 minus 3 squared plus 0 minus 4 squared. 6 minus 3 is 3, squared is 9. 0 minus 4 is -4, squared is still a +16. So I get the square root of 25 again, which is 5. So DE is also 5. Then I have EF. I've got the square root, and we've got 2 minus 6 squared plus negative 3 minus 0 squared. 2 minus 6 is negative 4. Squared is 16. Negative 3 minus 0 is negative 3. Squared is 9. So once again, I end up with a distance of 5. Then I got to do FG. So we've got the square root of negative 4 minus 2 squared plus the square root of negative 4 minus negative 3 squared. Negative 4 minus 2 is negative 6 squared is positive 36. Negative 4 minus a negative becomes plus. Negative 4 plus 3 is negative 1. Squared is 1. So this one's the square root of 37. And our last one would be GC. So I have negative 1 minus negative 4 squared plus 1 minus negative 4 squared. Negative 1 minus negative becomes plus. So negative 1 plus 4 is 3. Squared is 9. 1 minus a negative becomes plus. 1 plus 4 is 5. Squared is 25. 9 plus 25 gives us 34. So then I've got the square root of 34. So to find my perimeter, add them all together. So I've got 5 plus 5 plus 5 plus the square root of 37 plus the square root of 34. And to get to the square root in calculator, it's second and then the x squared button on the left-hand side. Plug all this in your calculator because it wants you to round to the nearest hundredth, and we should get 26.91 units. So now I'll just erase this slide so I have room for the area. So now we're given triangle ABC with an altitude CE. Remember how altitude is the same as height. Alright, so I'm going to graph this triangle real quick. So I've got negative 4, 2, negative 4, negative 2. There's A, and then you've got 8, 7. There's B, and then we've got 1, 8 for C. There's triangle ABC. Oops. And then at 4, 4, 1, 2, 3, 4 is D. And it tells us that's the altitude. Alright, so to find the area of a triangle, I have to do 1/2 base times height. So I need to know the base and the height. Well, in this case, the height is the altitude CD, and the base is whatever it makes a right angle with. That would be AB. So I'm going to have to find the distance of both of those. So if I start with AB, distance AB, you plug in 8 minus negative 4 squared plus 7 minus negative 2 squared. 8 minus negative 4 is 12. Squared is 144. And 7 minus negative 2 is 9. Squared is 81. 144 and 81 gives us 225, and the square root is 15. So this base is 15 units long. Then I got to do the same thing for CD to find out how long the height is. So I've got 4 minus 1 squared plus 4 minus 8 squared. 4 minus 1 is 3. Squared is 9. 4 minus 8 is negative 4. Squared is 16. 9 plus 16 gives you 25. So the height is 5 units. So I'm just going to plug in 5 and 15 to my formula. So I've got 1/2 times 15 times 5. Alright, 15 times 5 is 75. Half of 75 is 37.5. And that's square units. Okay, then it wants to know, to verify that CD is indeed an altitude, which means it has to be perpendicular to the opposite side. So I'm just going to look at their slopes. If I look at the slope of CD, I start up here and I'm going to go down 4, right 3. So that's -4 over 3. If I look at AB, right, to go point to point, I'm going to go up 2, 3, 4, 5, 6, 7, 8, 9, and over 12. And it's a positive. So I'm going to go up 9 over 12, which simplifies to 3 over 4. To be perpendicular, it's got to be opposite reciprocals, in which 3/4 and -4/3 are. So it is indeed altitude. And for the next one, we've got the coordinates for the vertices of quadrilateral MNPQ are as follows. And you want to classify it as parallelogram, rhombus, trapezoid, and whatnot based on its properties. So if I graph it first, I've got 3, 0, 1, 3, -2, 1, and 0, -2. That's terrible drawing. Okay, so a couple properties that we can look at. We need to look at the angles to determine if it's just a parallelogram or if it's a specific rectangle or square. And then we need to look at the length of each side. So if I start with the slopes, okay, the PN, I go up 2 over 3, so that's a positive 2/3. QM, I go up 2 over 3, positive 2/3. PQ, I go down 3 over 2, so that's -3/2. And NM, I go down 3 over 2, so that's -3/2. So I can definitely get this down to specifically a rectangle because our sides are not only parallel, but they form right angles, they're perpendicular. So now it's a matter of if it's a rectangle or a square. So I'm going to find the distance of all of my sides. So if I look at MN, I have the square root of 1 minus 3 squared plus 3 minus 0 squared. So then 1 minus 3 is -2 squared is 4. And 3 minus 0 is 3 squared is 9. So that's the square root of 13. Then we've got NP. So we've got -2 minus 1 squared plus 1 minus 3 squared. -2 minus 1 is -3 squared is 9. 1 minus 3 is -2 squared is 4. 9 plus 4 equals 13. Just because these two sides that are next to each other, adjacent sides, are the same, that tells me that all of them are going to be the same, so we can classify this as a square. And the properties we use the slope of all sides and the distance of each side. And the last one, we have to squeeze it in. I have this rectangle that I'm going to graph, and I want to find the fourth point based on the properties of a rectangle. Alright, here's my graph. I had a little grid and a little sloppy, but I have my 3 of the 4 points. Okay, properties of a rectangle is that opposite sides are parallel. So if I look at the slope of AB, I know that from B to A, I go up 2, left, 5. So I have a -2/5. Right? That means that the same slope has to happen from C to D. Okay, and I only did that one time, which means from C, I can go up 2 over 5, 3, 4, 5. And that point right there has to be D. And that point happens to be 1, 2, 3, 4, 5, 12. So D is at 5, 12. And to verify that it is a rectangle, you just need to double check to make sure that opposite sides are parallel and that each corner forms a right angle by being perpendicular. So I know that this slope is -2/5. To go from A to D, we go up 2, 4, 6, 8, 10 over 4. So that is a positive 5 over 2. And likewise with BC. So they're parallel and then perpendicular in the corners. So yes, it is a rectangle.